Okay, for this lesson, we'll be starting on topic 6, part 2, which is a definite integral, right? So if you notice that, number one, the difference between this and topic 6, part 1 is that part 1 is indefinite and part 2 is definite. So the difference between this is that indefinite, right, is basically where you see that in part 1, you are doing an integration, okay, and there is an arbitrary constant, right? So the difference in definite and indefinite is that in topic 6 part 2, you will see that there are two extra numbers, right, on the right hand side of the integral sign, a and b. Okay, so this a and b, they are the new thing, right? This is what makes the question integral definite. So when they put limits here, right, this is what we call the upper and lower limit. A is the lower limit and b is the upper limit. So what happens is this, okay, this definite integral, right, wherever we do the integration, I will show you later on that basically your answers will come out as numbers, right? So there's a proper sequence of reading the expression. Like if you see how I read the question, basically, right, we will read a to b, fx as integrate fx with respect to x, where x takes the value from a to b, right? Integrate fx with respect to x, where x takes the value from a to b. So how does this integral go? Alright, so if I give a curve with equation fx as shown, what does the integral, fx a to b represent? Now I'm sure also your teachers have told you that actually when you do integration, one of the purpose is that it helps you to find area as well as a volume. So when I integrate fx from a to b with respect to x from a to b, what happens is I'm actually finding the area underneath the curve from a to b. Okay, I'm actually finding the area underneath the curve from a to b. This is what I'm actually doing, right? So, and how do we calculate this area? Okay, so let me bring you to the next important theorem, which is the fundamental theorem of calculus. Now, if fx is continuous from a to b, okay, what does this mean in case you're not sure? This means that basically your x is a, including a and including b. And if fx is continuous meaning that there's no asymptote, right? It's something like, if I were to draw a line for fx, my pen does not leave the paper, right? You notice my pen doesn't leave the paper, okay? And you have a nice continuous graph that does not leave the paper from a to b. This is your fx. Okay, this is what I mean by continuous. It means that when you look at fx, there is a continuous line here. Okay, there is no gap in the graph. Alright, so then the integral from a to b fx, right, this area here can be found by just integrating fx dx with respect to x from a to b. And how do we calculate this area? Okay, what will happen is after we integrate, we will have an what we call the answer, right? The integral itself. We just need to substitute b minus substitute a. Okay, so let me give you an example. Okay, say I give you the graph probably like say y equals to x squared, right? And I throw you two values, probably from 3 to 4, x-axis, y-axis. And what I want to do is I want to find the area underneath. Okay, so let me show you how it's done. Right, I know that when I integrate x squared, right? Okay, we all know from part 1, right? We're going to get 1/3 x cubed, right? Because just applying the formula. So how does putting the limits make it different? Okay, so when I want to find 3 to 4, I'm going to put out here lower limit, upper limit, 3 to 4, and I will draw a square bracket around my integral from 3 to 4. Okay, let me show you how I calculate. So see carefully, pay attention. This will be 1/3. Okay, I'm going to use my substitution in blue. Okay, so you notice this part in blue. This will be 1/3. I'm going to sub in 4 cubed. Okay, minus 1/3. I'm going to sub in 3 cubed. Okay, So literally what's happening is you sub in the upper limit, you sub in the upper limit, and you sub in the lower limit. Okay, that's what you are doing here. You sub in upper minus you sub in the lower. Okay, and this will give you the area under the curve. 27 over 3, I think this is 9. So this is I think 21. Okay, it's 49, 27 minus 49. This is just, I think, 47 over 3. Okay, I'm just going to leave it as oh sorry, 37 over 3. Okay, I'm just going to leave this just an example that I came up on the spot. So I just want you to know how to operate this definite integral, right? No difference, but when you sub in, you basically minus sub in upper limit minus the lower limit. Okay, you notice that one thing is that I actually do not have any C inside. You realize, right? So you realize, how come there's no arbitrary constant like you see here in the notes, right? There's a lower and upper limit, right? And unlike topic 6 part 1, where you get an answer in X, definite integral gives you a numerical value. Okay, a numerical value. Oh, so let me talk about part B. Why is there no arbitrary constant? Okay, the reason is very simple. Right, if you notice that if I look at the question earlier, right, if you look at this for example, right, when we do the integration, there is basically no what will happen is that, okay, let's say if I were to do something like that, I integrate x squared again, dx from 3 to 4, and say like just now I write down 1/3 x cubed plus c from 3 to 4. Since I follow part 1, right, I know that there's an arbitrary constant. What you notice is that there is a 1/3 of sub in upper limit plus c minus 1/3 of sub in lower limit plus c. And what do you notice? Can you see that the c just cancels off, right? So in definite integral, the arbitrary constant basically is cancelled off. That is why that we do not have any upper limit. We do not have any arbitrary constant there. Okay, can also take note of this, right? For definite integral, there's no need to write plus c. All right, I go through the key points again. All right, there is an upper lower limit, number 1. Number 2, there is no arbitrary constant, right? No need for plus c because it will be cancelled off. And number 3, you must remember that you have the answers, right? You have numerical answers because you are subbing in values, all right? And also take note, after you do the integration, remember, put in a square bracket and put in the lower and upper limits outside. Okay, so just take note of presentation. Thank you.